All right, I want to clear up a few issues that I've been seeing in the previous Edpuzzle videos and in the quiz, the Zoom quiz. So let's just dive into some of these. So this question, I asked you to evaluate both expressions using -2 as your x value. I have an expression over here in black equals another expression over here in black, and those came from up here. Here's the full equation with x's, 3x plus 15 plus 7x all over 5. We plugged in 1 for x, equals 8 minus 3x plus 2x. And I plugged in 1 for x, and with that 1, we then simplified this expression and got 5, simplified this expression and got 7. Since 5 and 7 are not equal to each other, I've shown that 1 is not a solution for this equation. Right? I did that in the video. And then I asked you to do it using -2 as your x value. So I'm just plugging in a -2 where I had a 1. So 3 times, I'll write this again, plus 15 plus 7 times all over 5, right? This dividing by 5 is part of the expression. It's one of the operations in the original expression. And x, I'm saying, is -2. So I'll plug in a -2. And then simplify. 3 times -2 is -6. 7 times -2 is -14. So I have 3 terms here. One's forward. 15 minus 14 is 1. And -6 plus 1 is -5. Right? Back up 6, move forward 1, get to -5. Divide that by 5, I get -1. Or I can put it over here as -1. Now I could have said -6 plus 15 is 9, and 9 plus -14 is -5. I could have said 6 and 14 are both negative, so that's -20, plus 15 is -5. Either way, I'm getting -5 for my numerator. Divide that by 5, I get -1 for this left expression. For the right expression, that was 8 minus 3x plus 2x. And so I'm going to pop my -1 in there. I'm sorry, not -1, -2. There we go. All right, this was 1. Now I'm using -2. So pop my -2 in there. So I get 8 minus 3 times 2 is 6, but it's negative. So I'm subtracting a negative. That means 8 plus 6 plus 2 times -2. 2 and 2 is 4, but that's negative. So I've got 8, 9, 10, 11, 12, 13, 14. 14 minus 4 is 10. -1 equals 10. That is false. And that's what I asked you to write. Enter your final statement. For example, 5 equals 7, false. Right, there's my, let me switch colors. Here's my 5 equals 7, false. Let's see if I can aim that a little bit better. Well, here's my -1 equals 10, which is a false statement. So then I can say, therefore, this value is not a solution. That's what I was looking for. This statement is what I was asking you to type in. All right. Moving on, here's a question that I didn't ask, but I hope it was somewhat clear. For some of you it was. Sunset Scenes prints digital photos for 12 cents each plus $6.29 for shipping and handling. Your weekly budget for the school yearbook is $25. How many prints can you have made if you have $25? So he goes through the whole process. I'm not going to repeat his video. But his model is something like 6.29 plus 12 cents per print. Right, here's our fixed costs and our variable costs. We talked about that in one of my videos. But her budget is $25. So we don't have to spend $25, but we can't go over $25. That's what it means to be a budget. Technically, this is an inequality. So when we go through all of this, and he gets 155.92, which is an estimation here, we get 155.92, skipping all the steps in between here. It's not technically that x is equal to this, it's that x is less than or equal to that. Right? 156 is a lot closer to this value than 155, but x cannot be greater than 155.92. If I'm looking at the number line, here's 155.92. X is less than or equal to that. There you go. Well, 156 is greater than. So 155 is the most she can make, right? She can only get one print. She could get 0 prints if she wants and still be under budget. But if you're trying to get as much as you can with the money you have, 155 is the most number of prints she could buy with the money she has. Right? So even though this was presented as an equation, recognizing it as an inequality helps us to understand why he rounded down instead of rounding up, even though it was closer to 156. All right, another problem that was not mine. A lot of people had some questions about the $1.10 not being $1.10. My question is, how does $1 compare to 10 cents? $1 is not a dollar more than 10 cents. Right? 0 minus 0, 0. 10 minus 1 is 9. If this costs 10 cents, 90 cents more gets us $1.10, or gets us a dollar, and a dollar plus 10 cents is $1.10, right? I want these two to have a difference of $1 and add up to $1.10. So I take that dollar and go 5 cents above. If I subtract that, 5 minus 5 is 0, 0 minus 0 is 0, 1 minus nothing is 1. 5 cents plus 5 cents is 10 cents. So the sum, 5 and 5 is 10. The sum is $1.10. The difference is $1. Right? That's why it's 5 cents here, and $1 and 5 cents over there. All right. Now on the Zoom quiz, I went over some of these with each of you, but we didn't have a lot of time. So I want to walk through those two questions, looking a little more deeply. Right? So what you saw on the screen, it said simplify. Notice it doesn't say solve. There's no equal sign here. This is not an equation. And then it just emphasizes simplify your answer. It's kind of weird the way they often write it twice. So let's just look at one version of this. I have a 6, and then I have one of these braces. Right? We know the distributive property means whatever is on the outside of the parentheses, whatever is right next to the parentheses, is being multiplied by each term inside those grouping symbols. Well, here I don't have a parenthesis, I have a brace. And so wherever that brace ends, here it is, all of this is being multiplied by 6. So the last thing I'm going to do is distribute that 6 to whatever's left inside those braces. For now, inside the brace, what happens next? I have a bracket. So that bracket opens. Where does it close? Here. So I'm looking at this as all one chunk. Then I have a minus sign. So I have two terms here. I have a first bracket is my first term, minus second bracket is my second term. So before I can combine these terms, I need to simplify what's in this term first. So what's happening inside that bracket? I have a 4 next to a parenthesis, and then plus. So within this term, I have two terms. A 15 that's being added to this thing. So I have to simplify this before I can add 15. Well, 4 times something, if I knew the value of m, if I were evaluating this, I'd plug in that number, 19 or negative 2/3, whatever it is, plug in that value for m, do my subtraction, because that's what's inside the parentheses, and then multiply by 4. But I don't know the value of m. M is some unknown amount. I don't know what 5 less than m is. So my only recourse here is to recognize that 4 times something means I have 4 of those. M minus 5, m minus 5, m minus 5, m minus 5. I'm adding up 4 of those, which means I'm adding up 4 m's, and I'm adding up 4 negative 5's. So there's 4m, 4 times 5, 20. Now it's your choice if you want to think of this as minus 4 times 5, minus 20, or recognize minus means plus the opposite, so negative 5 times 4 is negative 20. Whether I write minus 20 or plus negative 20, we have to see those as equivalent. All right, so there's my first group here. Then I have plus 15. So let me erase all of this because I'm just explaining how the distributive property works again. Try again here. There we go. Move all of this up. So I'm kind of going line by line. Okay, so this was inside the brackets, distributing here, plus 15. The 4 isn't times the 15. I think you guys all recognize that. That's inside that first bracket. So now I can add the 15 to the negative 20. And that's what's inside my first bracket. Now this is as simplified as it can be. I can turn my attention to the second bracket, minus whatever's going on over here. So what's going on there? 3 times something plus 2, same basic structure. The 3 is being multiplied by 4m. The 3 is being multiplied by 2. And then this 2 is just sitting there. So that's the second bracket. 3 times 4 is 12 times m, 12m. 3 times 2 is 6. And then the 2 is still there. And 6 does not have a variable, 2 does not have a variable. Negative 6 plus 2. Negative 4. Right? And all of this is inside these braces. Right? Thinking of that fast and slow thinking. You want your brain to zoom in on whatever operation you're working on, in this case distributing the 3, and then going on here, but still have a sense of the big picture. Don't forget to put these braces in here so you can remember at the end the 6 is still times everything. Now, come on 6. All right. I have nothing in front of these braces, so I just have these two terms minus these two terms. Well, that minus applies to all of this. The 4 is just a 4. Come on. Minus 12m minus minus 4, those two negatives become plus 4. I can combine these terms now. 4 minus 12, that's negative 8. Negative 5 plus 4, that's negative 1. No more simplifying I can do in here. All I can do is distribute the 6. 6 times 8 is 48, but it's negative, and there's an m. 6 times negative 1. 6 times 1 is 6, but it's negative. So there's my answer. Negative 48m minus 6. Or we can put the constant term first, negative 6 minus 48m. In my version of this problem, they're both negative. For some of you, maybe one of these terms was positive. Maybe they were both positive. These numbers got shifted around each time through. Right? So that's how we're simplifying this. We're not turning m into 1 or turning m into anything. We have to recognize which terms are m terms, which terms are constant terms, and follow the multiplication and addition as we go along. Okay, one last problem here. Collect like terms. It doesn't even say simplify. So maybe that helped you guys out, recognize like terms are what we need to pay attention to. But we do need to simplify our answer. Right? So I'll look at a larger version here. I've got one term with a and another term with a. Notice in front of this term there's a minus, so that means it's a negative. So I'll lump those together. 11 halves a and negative 2/3 a. Well, the a is the same, so in that sense the units are the same, but the denominator is not. So let's get a common denominator here. 3 and 2 are relatively prime, so I just multiply by 3 over 3 and by 2 over 2. So that gives me sixths, 33 sixths. And 2 times 2 is 4. Now I have a sixths, or a sixth of a as my units. So that's sixth, and the a stay my units. 33 plus negative 4 is 29. 29 is a prime number, right? 2 and 3 both don't go into 29. We're done with that term. Now we can turn our attention to my b terms here. 16 fifths b, and again negative 7 tenths b. Right? Notice in my structure, by going down my page, I have space here to extend the rest of the problem when I get around to it, right? That 41 has nothing to do with anything right now, but it's still part of the whole expression. So now for a common denominator, 5 times 2 is 10. So I can just use tenths as my denominator here, right? There's no reason to go into 50ths or anything bigger than that. 7 tenths is still 7 tenths. 16 fifths, 16 times 2 is 32 tenths. Now I can subtract 32 minus 7 is, let's see, 30, that's 25 tenths b. Right, this minus was going here. This plus sign in front of the 16 fifths is still in front of that term here. The minus is still in front of 41. And I might be tempted to stop here, say this is my answer. But 25 and 10 have a factor in common, and the directions did say to simplify your answer. So 25 is 5 times 5. 10 is 5 times 2. So the 5's cancel. So my final answer is 29 sixths a plus 5 canceled, so 5 halves b minus 41. And that's it. I don't need a common denominator between these three because the terms aren't going to combine anyways. So we could multiply this by 3 over 3, multiply this by 6, so then everything is over 6, but that's not really considered simplified. So it is equivalent, but it's not better. We'll leave it right there.